All right, today we're diving into the tiny, powerful heart of our digital world, the semiconductor. It's the invisible brain behind, well, everything, from our phones to our cars. And you know where we're going to start? With pop music. Yep, you heard that right.
Surprising, right? But here's the thing. It's actually kind of true. Why? Because the lasers that read digital music are built on the very principles of semiconductor physics. And that's just a perfect example of how this incredible technology is hiding in plain sight in almost every part of our modern lives.
So, yeah, from your favorite pop song to the very device you're watching this on right now, it all comes down to chips. Our whole modern, connected life is built on these tiny, tiny slices of silicon. So the big question is, what exactly are they?
Okay, let's pull back the curtain a bit. What's the secret sauce here? What makes these little things so ridiculously powerful?
You know, the name semiconductor pretty much gives the game away. It's not a great conductor like copper wire, but it's not a great insulator like glass either. It sits right in that sweet spot, which means we can precisely control how much electricity flows through it. And that control, that's everything. And the perfect material for the job turns out to be silicon, the second most common element on Earth. Here's the catch, though. Pure silicon on its own, it's pretty useless for what we need. See, it's a perfect little crystal, so all its electrons are locked up tight. No flow, no current. The real magic happens when we mess with it a little bit, when we intentionally add some tiny impurities. And this process, it's called doping.
So check this out. If you add an impurity that has an extra electron just rattling around, you get what's called N-type or negative material. But if you add an impurity that's missing an electron, you create a little hole, and you get P-type or positive material. And boom, both of these new materials can conduct electricity, giving us that dial we can turn, that precise control we've been looking for.
All right, so you've got these two new types of silicon, N-type and P-type. What happens when you put them together? Well, you create what is arguably the single most important invention of the 20th century, the transistor. And this little device has two jobs, two incredibly important, world-changing jobs. It can be an amplifier, making a small signal way bigger, or it can be a switch, flipping a current on and off with blinding speed.
So let's talk about the amplifier first. Think about a microphone. The tiny electrical signal from your voice, it tells the transistor how much to resist a much bigger current. That bigger controlled current then powers a speaker. Your small voice becomes a huge sound. It's literally transferring a signal across a resistor. Transfer, resistor, transistor. That's where the name comes from. Pretty cool, right?
But honestly, as cool as that is, its job as a switch, that's what changed everything. See, by flicking fully on or fully off, a transistor can represent a 1 or a 0. And that right there